All right. For the second one, look, what a lot of you are going to want to do is you're going to start trying to double distribute to get this all put together as one thing. But think about what you're trying to do. You're trying to solve for roots. Do you want something to go back and have no parentheses when you're looking to solve for roots? No, your goal is to break it down into parentheses, correct? So you're not going to start going backwards and start getting rid of parentheses, right? And if you think about this, well, first of all, let's talk about it in terms of what's the degree of this equation. It's not 2, 4, because if you did do it out, right, your highest degree would be x to the 4th. Okay, so the degree of this equation is 4. So how many solutions should you have? 4 solutions, right? You know you're supposed to have 4 solutions, and look how it's broken down. Over here, if I just given you that, could you find how many solutions would you have? 2, right? Could you probably find it since it's a quadratic, right? And then over here, how many solutions are you going to have? 2, and it's a quadratic again. So do you understand what I'm saying? Why go back and start distributing? Now you're going to have to try to figure that out, which you're not going to be able to do, right? You kind of follow me there? So think about what you're trying to do. So we're already a step ahead of the game, correct? We're all ready to set these equal to 0 and figure them out since they're quadratics and we have alternatives. Let's start with this one over here first because it's easier. Why is it easier? Because A equals 1, right? It's just less work for me. If A equals 1, all I have to do is say, okay, what multiplies together to give me -4 and adds together to give me -3? That's going to be what? -4 and +1. So then I can do my 2 parentheses. I have to do all the grouping stuff. -4 plus 1 equal to 0. Now with this one, because A equals 2, what am I going to have to do? Well, I could divide by 2, but then I got a fraction, so I don't want to deal with fractions. We did this by grouping. Remember how we got it set up so we could group? We multiplied these 2 pieces, so we said, okay, what multiplies together to give me -2 and adds together to give me +1? What's that going to be? -1 and 2? But that wasn't my answers, that was the values I needed for grouping, right? To get my terms. So then I have 2x squared minus 1x plus 2x minus 1 equals 0. So now it's still equivalent, because this middle term I just changed to 2 pieces. And then I go to group. What's my GCF over here? X. Left with 2x minus 1. And I need this to be 2x minus 1 over here. So what do I GCF out of that? You got to GCF something. +1, right? So +1 here, so I don't change anything. 2x minus 1 equals 0. Do not leave it like this. You got to finish before you start breaking it down. So this factors into what? One more GCF. X plus 1 times 2x minus 1. Still equals 0, and now I can solve. X plus 1 equals 0, so x is equal to -1. 2x minus 1 equals 0. X equals 1/2. All right, let's just go back to this first one because we didn't check it. Let's go back to this one. How can I check this real quick? By doing what in my calculator? Storing, right? So intrinsic storing 0. Okay, store this. 1/6i. Remember where your I key is? Down towards the bottom. So store your 1/6i. Some calculators you're not going to be able to put it in as I over 6. It's not going to let you do that, and then other ones will be okay. You got to figure that piece out. Some people have to put in 1/6i, or it's going to say 8. You know they come in pairs, so I don't have to check the other one, right? So I can check one of them. And you put in stored 1/6i, and then you type in x to the 7th plus 36 x to the 9th equals 0. Or not equals 0, but just, and then hit enter. Did you get 0? Yeah. You did? Anybody get anything like not zero? Like, yeah, you got, what'd you got? 0.02. Then what? You have an E?
Really long.
Alright, I don't know what yours is. What? I don't know, try that again. What do you have? Yeah? Negative 7.14
490,169 E negative 19.
E negative 19. Okay. So on this one, this is really scientific notation. So this really means that negative 7.144906 times 10 to the negative 19th power. That's what that means. And so remember scientific notation, that would be you moving backwards. So it's negative 19. So it's really like 0.0000000000714, blah, blah, blah. You see what I'm saying?
Yeah.
So sometimes your calculator, because it rounds in the middle of solving things, you're like, in other words, you need to be smarter than your calculator. That is really 0 to your calculator. Because it's so small, it's like 0.000. Okay? So you gotta make sure that you're clear on that kind of stuff. Alright. Okay, we checked that. We feel pretty good about that. Alright, how else could I check this one? I could certainly store all these numbers and check them all.
Wait, I have a question.
Yep.
Number one, how would you check it if you didn't have your calculator? You already said that most of the time you won't have your calculator.
No, I said you will have a part of your test that is no calculator.
Okay, well, in that case, how would you?
You wouldn't. What else? I mean, you could put it in yourself and do it, I guess. You be careful. All right, how would I check this one? Yeah, go check this in the graph, right? Type in the original, just like you see it with the parentheses. And what are you looking for in your graph? Because all of these are what kind of roots? Real, right? So what are you looking for? X-intercepts, correct? Alright, you got typed in? Now there is something weird on this one that we haven't talked about yet, but we will when we're doing a sketch. Okay? You look at this graph, and it definitely goes through a 4, so we're feeling good about that, right? Our one answer was 4, one answer was a half, looks like it's going to be a half there. I can double check it. Now, why? Look at this, it's not going through, it's like turning around, isn't it? Why do you think that is? Yeah? Because you had -1 occur how many times? Twice. Okay, that's called the multiplicity, we'll talk about that in a couple days. But you have to be able to, you're going to see that, and you're going to be able to sketching it, you're going to have to know what that looks like. Okay, so the reason that this looks a little weird and it doesn't go straight through is because -1 happened twice. That's something to keep in mind. Okay, yep.
So -1's still worth though?
Yeah, it's a solution. You look at the table, right? You look at the table at -1, it's a 0, right? -1, 0. Okay? That's still a root, still a solution. It happened twice. Alright, so we checked all those.
Yeah.
What's that? So our goal here, starting tomorrow, is to be able to look at an equation like this and say, it's a degree 4, which means we know what about the end behavior. Uh-oh. We better know this by tomorrow. Either opens up or opens down, right? End behavior. How do I know if it opens up or down? You look at the lead coefficient, which in this case, if I were to distribute, wouldn't that be 2x to the 4th? Right? So it would be positive, so it should open up end behavior, which it did because we looked at the graph, correct? So there's your end behavior, all right? So it should open up end behavior, and then it should cross at these points, right? And then we would talk about multiplicity and what happens there. Yep.
On the graph, after it hits -1 and goes back up,
Mm-hmm.
it goes to 4. Is that because of degree 4?
No, it goes to 4 because your y-intercept is 4. Right? Can you say it goes up to 4, like crosses the y-axis at 4?
Yeah.
Yeah, because if I fill in 0 for x, right? If I fill in 0 here and 0 here, isn't that gonna make this whole parenthesis -1? And if I fill in 0 here and 0 here, I make this parenthesis -4, -1 times -4 is 4, right? Your y-intercept is when x equals 0. Anything else on that? Okay, that's another quick thing you find. All right, let's try the next one. A number 1. Okay, well, I did not put that in. What degree is this? 4. How many solutions are you gonna have? Are they all real solutions? Are they all real solutions? I don't know. Maybe. Do they have to be all 4 real solutions? Could they be all imaginary solutions? Possible, right? Could it be 2 real and 2 imaginary? Could it be 3 real and 1 imaginary? No. 1 real and 3 imaginary? No. Okay, so we want to solve this. We've done this before, but for some reason we don't remember it. Is there a GCF? No. All right, back to it. Nope, I don't need a group. Okay, what if it was this? Would you be okay? What would you do? Multiplies to 4, adds to 5. And you would say it's x plus 4 times x plus 1 equals 0, correct? What's the only difference here? It's x to the 4th and x squared instead of x squared and x, correct? Okay, so what is this going to factor into then? X squared plus 4, not a plus 4x, plus 4, right? And x squared plus 1. So look, this right here would give me my x to the 4th. We're good there. My outer and my inner added together, are they both x squareds? Yes, right? There's your 1x squared plus your 4x squareds, which gives you your 5x squared. And then the last one gives you your 4 in the end. You good there? It's really no different than this if you've got a 4th and a squared. All right, now we have to solve it. Now they're both quadratics. So we can solve, right? On my line, x squared plus 4 equals 0. X squared plus 1 equals 0. Dots? Yep. X plus 1, x minus?
No.
Nope. Why not? Perfect square, perfect square.
Subtraction.
Not subtraction, right? So I'm going to subtract x squared equals -4. X equals plus or minus square root of -4. X equals plus or minus 2i. 2 imaginary. X squared plus 1 equals 0. X squared equals -1. X equals plus or minus square root of -1. X equals plus or minus I. Okay there? All right. Tell me what you know about this graph before we type it in. We're not going to cross the x-axis. You agree with that? It's going to open up, and behavior is opens up, right? So we know it's going to look like y-intercept is 4. Do we agree with that? So we know it's going to go through at 4 here at some point. It has end behaviors that looks like this. I don't know what's going on in the middle. It could dip and come back up. Who knows? Right? Something like that probably. Go type it in. See if you're right. But none of it is below the x-axis, correct? Because otherwise it would have to cross sooner or later. Okay. All right, good on that? All right, what about this one? What do we do here to find the root? How many solutions are you going to have? 3, right? All real? Maybe, right? Maybe not. 1 real? At least 1 real, correct? Do you agree with that? It's got to be at least 1 real. Could be 3 real, but it has to be at least 1. All right, so what do we got? What do we do on this? Group it, right? So 0 equals, what's my GCF on my first 2? A squared. That's with k plus 2. As long as I can get this to be k plus 2, I'm good to go. What do I need to pull out that makes that k plus 2? -1. Do my final GCF, do not leave it like this, you're losing points. K squared minus 1 times k plus 2. K squared minus 1. Stops, right? K plus 1, K minus 1, K plus 2. Alright, ready to find them? They're going to be what kind of answers? All real, right? K equals -1, K equals +1, K equals -2. So like here's what I mean by where we're headed. I know that it's going to cross at -1, so if this is -1, +1, -2, right? I also know the y-intercept is going to be what? -2 if you fill in zeros for everything, right? This is where we're headed tomorrow. What do I know about the end behavior? Low to high. It's odd, and the lead coefficient is positive. So I know it's going to start down here somewhere low, and then it's got to go through here. And it's got to come above at some point, but then it's got to do what? It's got to turn around and come back through, correct? Then it's got to come down, it's got to pass through -2 at some point, but then it's got to turn back around, it's got to come through that point. I don't know how high it is here or here, but based off of how far apart things are, I could probably get a pretty good idea. Good? So you get like a rough idea of what we're doing? And how you'll be able to put the pieces together. If you type that in, it should look pretty much like that. Alright, how about this next one? Here's where you gotta be a little bit careful. You can't just add, like you do when this is squared, you just add and then we square root and you're like plus or minus. If you do that with fourth root, it's not gonna work. You're gonna lose value. Okay? So what do we got going here really then? If I can't just move the 1 over and divide by 16, what can I do? Dots. So you got dots here. Perfect square subtraction. So 4x squared minus 1, 4x squared plus 1. Now what? Dots again on both? No, just this first one. So 2x minus 1, 2x plus 1, leave my 4x squared plus 1 alone. Now I've got linear factor, and a quadratic factor, so I should be able to solve. They're broken down far enough for me to be able to find all my solutions. So 2x minus 1 equals 0. Means x is a half. 2x plus 1 equals 0. Means you should be getting -1/2. And then what about this one? 4x squared plus 1 equals 0. Subtract. Divide by 4. We're back to what we had at the beginning. X equals plus or minus square root of -1/4. Take your I out. Those are both perfect squares. X equals plus minus 1/2 I. You can check in your graphic calculator, store and check your solution. Questions on that? All good? Alright, what's the degree of this last one? 3. So we're going to have how many solutions? 3. Which means at least one of them has to be real, correct? Okay. Am I going to go ahead and double distribute this and get rid of the parentheses? No. I'm trying to find the zeros. Why make it right? We're going to have to factor anyways. Am I set and able to go from here? So I got one that's linear and I got one that's a quadratic, correct? So I'm feeling pretty good about that because I got options. If I draw my line, I got x squared minus 5x plus 7 equals 0. I got x minus 2 equals 0, so it's easy, x equals 2. Here's a solution. The other one's not bad either, right? I need to multiply together to give me 7 and add together to give me -5. No? So what do I do then?
Quadratic.
Quadratic equation, right? It's quadratic, I can do quadratic equation on there. So x equals, negate my b, so positive 5 plus or minus, I'm gonna do my discriminant down below, over 2, discriminant b squared minus 4ac. What's the b squared value? So we avoid making careless mistakes. 25 minus 4 times 1 times 7. Write that all in your crossing calculator. For discriminant. -3. Put it back in. What kind of solutions we getting? 2 imaginary, 1 real, right? So x equals 5 plus or minus I radical 3 all over 2. Did they tell me it had to be an a plus bi form? No, then just leave it. You don't need to. You can move it around if you want to, but if you make a mistake, then you're losing a point for no reason. Good. If you need to plug it in your graphing calculator to check it, then, and your graphing calculator is not, won't let you put it in this format, then you'd have to, it would end up being 5 halves plus or minus radical 3 over 2i. You might have to put it in that format to check it, depending on your graphing calculator. Questions? We're good? All right, working on your homework. You have some in your packet, you have some in the book.